Hey guys, so welcome back to our channel Animating AI, and today we are going to see how uh, gradient descent helps us to find the ideal line for linear regression. So in the last video we have seen that first our linear regression uh, creates a normal line and then it calculates the residuals. So if you see in the screen, we have a line and then we have all the data points. Now this line is not an ideal line for linear regression, and we can see all these orange dotted, these are the residuals. So our blue line is our predicted line, which you can call it as y hash, and whatever the dotted residuals you are seeing, this is the difference between your actual line and your predicted points. So the idea behind the gradient descent of cost function is we want to find the ideal value of our slope and intercept. So as we say, the core, the backbone behind the linear regression is our this function of line, which is y is equal to mx plus c. So what we want to calculate here is x is our dependent variable, independent variable, and y is our dependent variable. So we want to predict y here. We have the values of x, and in order to get the ideal line, we want to calculate m and c here. So next we are going to see is how our cost function calculates the ideal value of theta, which is also your slope and intercept. Now if you see the current graph here, this is how a gradient descent works. Now let's, at the left we can see the formula of cost function. So the formula says 1 upon n summation of I is equal to 1 to n yi minus yi hash the whole square. So basically it says that for all the data points that we have, we want the actual value minus the predicted value, the whole square, and then we are going to put it in a graph where the point where currently the dot we can see is, it is global minima. So if we just come back here, we will see that this was not always at the global minima. The point started somewhere here, and then slowly it came down to a particular point where the slope of this particular point with respect to x is 0. So a point where slope becomes 0 for that particular equation, that is the point which we call it the ideal value of your slope and intercept, or you can call it as a global minima, or you can call it a point where slope is equal to 0. So we can see that in the formula also, this formula will get applied, and then we will have a ideal values of m and c. Now just see here, previous line was passing like way away from our points, the actual points, but now after learning from gradient descent, it is passing precisely where the residuals or the entire summation of residuals will be minimum, and we can see the actual calculated value of our slope and intercept, which is 0.98 and 0.26. So this is basically how initially our linear regression calculates a normal line, which is like a random line you can call, or a constant line, and then all the values of our predicted and actual points are passed through cost function, and then it calculates the ideal value of m and c. And then once this line is plotted in future, so we can see here x axis 1 2 3 4 5, these are the independent points, and the predicted points are on y axis. So in future, let's say we have next point 6 7 8, we can check on this particular green line that for a particular point on x axis, what will be my value on y axis. So this is how in simple nutshell it works. So thank you for watching. We will meet next time on new topic on probably logistic regression. Till then, goodbye.